We wait for some time. Not sure if people are joining.
Hello everyone.
Yeah, hi, Alan. Good evening.
Hello, good evening.
We'll wait for a couple of minutes. Let's see if more people are joining. So then we'll start.
Sure. How many people registered for the meetup?
I could see around 15 people.
Okay.
Not sure. Will join. We'll wait. Okay. So we thought we'll wait. I think we are overshooted by 4 minutes. So we'll slowly start. I think if anybody is joining in between, we'll be happy to welcome them. So this is meetup number 7 in 2026. Actually, it's the first meetup. So we had few virtual events and hybrid events and physical events. We have tried out everything. And in 2026, yes, we couldn't do it in the month of Jan and Feb, so we have started it this month. So going forward, we will be trying to make sure that we have at least one meetup every month. Um, uh, we're slightly disappointed with the responses, though we have a very large community. People don't turn up as they promise. That is a bit of disappointing. Uh, but again, okay, that's should not be our focus anyways. So we will be continuing to do this and putting this effort in a consistent manner. That should be our focus. So having said that, thanks, Aryan, for joining. I think only you have joined externally from the list of people who registered. So nevertheless, we'll start. I'll quickly tell what we have lined up for today's meet. So this is the agenda for today. So we'll have short and crisp sessions, which is um, uh, across various topics like Ceph and OpenStack, which is our topics of interest majorly. And first, we'll have a session from Likit on Ceph, and followed by another 20-minute session from Krishna Raj on OpenStack high availability layers, and then followed by Deepak presentation on again Ceph. So each of these sessions will be a 20-minute session, and I think some of them also have a demo to show, and I'm sure it is going to be quite interesting topics. Also, when it is with the demo, it is doubly interesting. So we'll have a 20-minute session by each of the speakers, and followed by 10-minute Q&A. If there is any questions to be asked, I think we can get it clarified after the session. So last, I'll be speaking on what we have been trying to do so far and what is next for the Open Infra user group in India. So we have quite interesting plans, which I would like to convey to the community and see how things roll forward. So that's all from my side as an introduction session. So we will just quickly jump to the interesting sessions. So first, it will be Likit who will be talking on automating Ceph, and that will be a 20-minute session, as I said. Just handing over to Likit for now. Thank you. Likit, please continue.
Yeah, good evening.
Likit, your mic is not.
Yeah, there was a bit of interruption.
Hello, is it audible now? Okay, I'll just
Yes, yes, it is clear now.
okay, just a minute. So, first of all, hi everyone, good evening. So, hope my screen is visible. Uh, so before starting, I'll give a short introduction about myself and then we'll proceed. So, I am Likit. I am from Bangalore and I'm currently working as a cloud engineer in a company, Pinakasra. So, one-click application deployment on Ceph is my topic today. And today I'll be showing a simple tool which is used to automate the deployment of an application on top of a Ceph storage. So let's go. So this is our today's agenda. So I'll be briefly explaining about the tools overview followed by automation, architecture, and then at last a live demo of the tool. So what does this tool does? So this tool is used to deploy an application on top of an Ceph cluster, which is which does the things like a storage provisioning in Ceph, storage provisioning such as creating a storage pool, making it usable, and mounting it in a system, and then on top of it running an application where the where it makes the user directly access the storage. Okay, I think most of us here would be knowing about the Ceph. If not, then I'll give a short explanation. So Ceph is nothing but a storage backend, which we can use, which we can deploy it in our hardware and start using it. But if you see natively Ceph, to create storage pools or block something, etc. So there we need some little much more of learning, like to understand the dashboard or whether if it's a CLI to learn the commands. So today, if someone is new to the Ceph and they don't want to just go deeper into it, just use it as a storage. So this tool may be the right for them. So automated workflow. So in our tool, this is what happens in our backend as I've simplified. So things like pool creation, RBD volume, mapping, etc., and deploying application, and finally an UI where we can use it. So this is our architecture. So if you see at the top, there is a pool. So the first pool will be created, initialized, and then inside that pools, multiple RBD volumes will be created. And those RBD volumes will be made as, will be formatted and mounted it in the system host. And on the top of that path, this Docker container, there is a open source image called file browser, which gives an ready UI to use this file system. And once the container is up, the user gets an UI friendly browser interface. So the plus point here is multiple volumes can be used inside a folder. Like we can folders in the sense, I mean it as a volume actually. So once the UI is up, you can add multiple volumes and start using it. So these are our key capabilities. Like instead of multiple commands, like if you're doing this process manually, that's like we have to create, the user have to create a pool first, initialize it to as an RBD pool, and then create a volume manually, and then etc. He need to then run this container or some other alternative things. So using this tool, as I said, we can make it simpler using a just using one script. Also, the key capabilities, if you see, we can add or remove volumes without even restarting, when without stopping the Docker application. And it is properly compatible with the Ceph, actually tested with it. So now let's quickly go into a live demo. Just so where we will deploy this application, access the UI, and create file, upload, and verify in Ceph whether it is really getting stored there, and add volume dynamic. So this is the folder. Actually, I have my scripts here. So there is a total of 4 scripts. So the first script we will be starting is the deploy script. So I'll just start it. Deploy Ceph. So here we will get an interface where we can select an application. Right now, only one application is there. So if you want, we can, on top of this, we can add multiple applications. So right now, this tool is only made for file browser, which is accessing the storage easily. So and further, we can also add new features. So I'll go with the one file browser. And to run the application, we need to mention the port, like whichever port. I'll mention 9876. You can see the port is available and all the prerequisites are checking. So here we will get an option whether to create a new pool or use existing pool. Now I'll go with the new pool creation. I'll name this pool as OpenInfra pool and image name. So the image which gets RBD image which gets created inside that pool. Name it as OpenInfra RBD image. So and at last we will be specifying the size of the image. So I'll go with the minimal size. I'll go with 1 GB. This is it's in MB, and we'll get a configuration summary just for confirmation. All the ports, action, and the pool name followed by image size, and this is the mount path where in the system this image will be get mounted as a file system. I'll confirm it. So here the storage provisioning is happening. Nothing but the pool creation uh, followed by some image creation, making it, initializing it, mounting it. As you see, it is mentioned as preparing storage. So, and at last, this application runs, deploying file browser, the image with the open source image which I told. So as you can see, the deployment has been successful, and followed by you'll get an URL with the default password, which is admin and some password. So I'll just open it, copy this, open it in my browser. So this is the UI login. So if you see right now in the first initial deployment, I've just selected one image. So this is the global path where we are right now actually. So this is open RBD image is the image which I created earlier. I'll just confirm. We can see the pool which we mentioned has been created here. We'll check the image. You can see that the image and pool has been created successfully. So now let's go and create some files uh, inside open. Okay, I've opened this image. This is the root path of that volume. So I'll create a new folder here. Name it as I'll name it as folder one, and along with it, I'll create a file inside it. Create as hello. Yeah. Okay. So I can also write something. I can inside this. I can also give some message, and I'm saving it. You can see the file has been created, the folder and the file has been created here successfully. Now let's verify this from Ceph, like whether this has been created successfully, like whether this is really backed by the Ceph or not. So I'll go to the path where this is mounted. Just a minute. As I said, this Ceph volumes is a global path where under this all the images will be mounted. If see, this is the same folder which we saw in the UI. Now let's see whether the folder one is actually created here or not. Go inside it. Yes. You can see that the folder is here, which confirms that the what and all we are creating is really creating in the Ceph. It is backed by Ceph. Let's check whether the message. Actually, due to permissions, since it is mounted from the Ceph, due to permission from here, we can't view it. Let's upload some files here from our system. Local system will try to upload some files. And go to downloads. Here you can see it. It is getting uploaded. Let's wait for it. can see it is uploaded successfully. Now let's check it here. You can see that the GitHub desktop setup which I uploaded in the UI is showing here. So now what I showed was just single volume. This was just single volume which I mounted it. Now let's add another multiple volumes. Try adding it. So for that I have another script, the same folder. Add Ceph volume. Here we need to, the pool is already selected since the deployment, the initial application deployment is done. The pool is already selected. We just need to give the volume name. I'll give it as volume 2 and the size. It is asking for confirmation. Just we need to confirm. You can see it, the initialization started and volume added successfully. So now let's check it. Let's refresh. Yeah, here you can see that immediately without making or without stopping this application, it is updating. I mean, it is adding the volume. Followed by here, let's create one folder here. Looks like from this there is an issue. Okay, let's check it from here. Volume. From now, let's create one file here and then let's check it there. Sudo. Let's can see here the file empty file has been created here. Let's confirm it there. Looks like some permission issue, guys. Let me check. And now let's remove this. Let's try removing this volume from this. We have another script for it. Okay. So to remove a specific volume, we have this remove ceph volume.sh. So here you can select the volume which you want to remove. Now I'll remove this volume 2. Give it as 2. Here it will ask for a removal option, whether you want to just unmount and unmap. This is nothing but without deleting the image, just unmap from the system or delete it completely. We'll go with this delete completely. So where the whole image will be deleted. Just need to confirm it. Yeah, here you can see that the volume removed successfully. Now let's verify it. You can see the volume has been within with a refresh, it is getting removed. I mean, it's getting updated. So the next, so now we have covered this initial deployment of this application, add volume, remove volume. Now I'll show you the clear setup. Like what and all we did, we'll just clear all the configurations. This will remove the pool which we created along with the image, and it will stop this container, I mean application. Clean file. So here it is asking which pool we want to remove. I am giving it as 4, the one which we created. Is asking for confirmation. You can see that it is all the mappings has been removed and it is unmounting the volumes. You need to confirm it. And open just for confirmation, it is asking to type the pool name. Yes, you can see the clean has been completed. Now this application would have been stopped. I'll refresh it. the application. So all the things which we done has been cleaned up. So this is so that's all from my side. So if there is any doubt, I'm happy to answer. Or if you want me to show it again, I'm ready.
Thanks, Legit. I think that was interesting tool, very simple, rudimentary tool. I think whoever is who wants to build a UI on top of an existing set cluster and maybe for a home backup or something like that. Definitely not a production grade application, but still a small application which can be used for a home lab or something like home backup solution, something like that. So it is quite interesting. Do we have this tool available for file systems and object storage as well, or only
Uh,
for?
no, no, only for this RBD action.
Okay.
Okay.
So anybody else has any questions on this?
Yes, thank you so much, Likit. So I'm completely new to infra, but it also made sense to me. Thank you for simplifying the idea here. So I had a question. When you're using Ceph, how exactly do you go about secure keeping data encrypted at rest? Is there any feature available in Ceph, or do you have to build it on top of Ceph? How is it gonna be?
Like you're asking from this the tool which we I just executed now, or from the native Ceph itself?
I'm asking from Ceph itself.
Okay, actually in Ceph for data encryption during the Ceph deployment itself, I think we can have it is AES 236 encryption.
Okay.
So which encrypts the OSDs completely on data at rest. So the OSDs will be only accessible when it is accessed by the specific cluster where it is deployed. So even once the OSDs drive is removed, so outside it cannot be, no one can be able to read it or view the data.
Okay. Thank you.
Okay, thank you. So any other doubts? Yeah, then I think
No more questions? Yeah, definitely you can reach out to Likit if you have any help required on the Ceph front, right? Because this is a very small topic, but definitely Likit knows in and out of Ceph. So he has been working at Ceph internals for a long time now. So if you need any help or maybe you can connect with Likit offline also, and maybe he can take help from you guys as well. So if you have interest, please do connect with him offline. He has shown his email ID and LinkedIn profile as well. You can always connect with him. Thank
yeah,
you.
definitely I would be
Yeah,
happy to help if there is any.
thank you. Thank you, Likit.
Yeah,
So
okay, thank you.
we'll quickly move to the second session. Uh, so the second session will be on OpenStack high availability by Krishna Raj. So she will try to explain different layers where high availability may be needed when it comes to an enterprise grade deployment. So just handing over to Krishna Raj for the next session. So just a quick bit, we are having these sessions as a 20-minute sessions. So it is crisp and clear. So if always we welcome people who have more interest, so they wanted to deep dive into these topics and understand more, or maybe share more details with the community, we always welcome. So each of these sessions are 20-minute sessions to make sure that we have the highest level of attentiveness from that release, and then followed by their queries. So over to Krishnaraj now, and yeah.
So, hello everyone. Hope I'm audible to everyone now.
Yeah, Krishna.
So, good evening everyone. My name is Krishnaraj. I'm working as a cloud engineer at Technical School community, and I've been into OpenStack for last 2 years. And from this session, I'd like to share about the HLAs in OpenStack, and I will try to understand more about this. So, let's start from the first. Let's talk about first what is HA. HA is high availability. From the name, we can say the application should be highly available to the client, even though there is a single point of failure at the production level. We can't say it is the application is a production level without the HA. If there is if even there is a single point of failure at any point, then the service needs to be reachable to client at any point of time. So how HA is helpful in OpenStack? Mm, So OpenStack is a critical cloud configuration. So if there is any single point of failure in a cloud, that creates a huge impact in the client side and the server side. So in OpenStack, we group multiple servers together to provide HA. You can't only set up one server and say it's a HA. We need multiple servers, assign multiple rows to like controller, compute, storage, and network. Each perform specific tasks which works independently. One shouldn't affect each other. Yeah, the goal is simple here. Even though there is a single point of failure, the application should be keep running and serviceable to the client. So without HA, even any one node, even if any control crashes, that can bring a whole cloud setup down. So So here in OpenStack, HI is not optional. It is mandatory in every production level grades cloud setup. So let's go to move to the next. Here we have layers in OpenStack in HI. First one is infrastructure layer, control plane, and data plane. Infrastructure layer, we'll talk about the server level, which comes the server components like network, NICs, power sockets, disk, and other components. And control plane, we have a core series of chip which will be facing the client, the users. You can see here the course subservice will be running in the control plane, which will be facing the users like dashboards and other using interactable consoles will be facing. So if this main thing goes down, we couldn't even access the OpenStack cloud. And the data plane here, which has the workload of our VM and data and everything like networking and containers, everything will be running in this data plane level. You can see from this diagram. In management plane, we have a developers team, operation team, security team, and platform team. They will have access to the dashboard which is provided from the control plane, which will be manages the workloads under the users will be given through the dashboards. Control plane sees the request and decides which node has to perform this operation. Let's move to the next one. First one, first layer. See here the main component compute nodes, storage nodes, network switches. See Here, if a client gives a request to the server, if here if there's if it's only one server and if it goes down, the user can't get the response he has to get. So we are using redundant servers here. So if one server goes down, the other server will take on and replace to the client here. And the RAID level for disks. See, for disk, if you, if you use a disk without a RAID, if data loss in that disk, that will can be recovered from at any point of time. If you use RAID, the two disk or three disks will be mapped together and work as a single disk, and data will be written in every disk. So if even if one disk goes crash or data been corrupted, the other disk will rewrite the data to the disk and make it available to the user. And the NHC server, in NHC levels, we have bond. What bond is? So let's say we have four NICs. We will bond two NICs, and these two NICs will work together as a one NIC. So one will be in a standby and one will be in the active mode. So if one NIC goes down, the other one will take care of the traffic here and dual power supplies. Unlike normal machines, we have two power cards here. So if one power card goes down or power supply been cut off, the another will take care of the server. So there will be no power set time there. And multiple switches. In normal setup, we will use only one switch. Client gives the request, it goes to the switch and it directs to the server. It will be both incoming and outgoing will be in same switch. It's a lot of traffic. Maybe the switch can't handle and maybe the pack it goes drop and the client can't receive the response he has to receive. So here we will use multiple switches. One is for incoming request and one is for outgoing request. So the whatever the client gives the request, it will be received from one switch and direct to the server, and the response will be received by the different switch. So there will be no chance of packet losses here. So what are the things handled by this layer is node crash will be handled here, and disk failure using the RAID will be handled here, and network by using modern NICs and the multiple switches here. Let's move to the next layer, control plane, and it's the most critical layer in OpenStack, which runs the most crucial and the most important services in the controller nodes. Example, Keystone. It's a authentication service which provides access to the users based on their roles, based on the domain they assign to, based on the project the user is involved. If this goes down, the user can't even access the console itself. And next we have a Nova. Nova is nothing but the gives the computation power to the OpenStack, like VM creation, container creation, and other computation services. And the APIs will be running in the control plane, which gives the request to the compute nodes. If this goes down, we can't even access the workloads which will be running in the compute nodes. And next, networking. Already we call the services Neutron. And yeah, if this goes down, we can't even access any data in the VM and the disk. We can't even access the VM also. And the storage here, and which provides storage for the VM and other computers resources like DB services and container services. And next, glance images, which is imaging services for the VM, like Windows, Linux, and other OS will be stored in the glance. This are the main service will be running in the control plane. If this goes down, we can't even imagine what would be the level of the server there. So you can see the diagram here. Most critical services will be running in this one, and the network's related service like neutron, metadata, L3 switches will be running in the network host. And computers, you only have the computing services over compute neutron and L2, which first acts to the machines everything. And how it's handled in control plane. It uses HA proxy. It's HA proxy nothing but the load balancer here, which distributes traffic across all nodes. Instead of pointing in only a single node, distributes the traffic across all nodes. So based on the workloads. And the next VIP. And a single VIP, that's nothing but a virtual IP, which is assigned to a controller node based on based on the number of nodes. The cable will be running in each and every controller nodes, and by instead it will be assigned to one controller node. If that controller node goes down, the IP will be assigned to the next controller node. So the console will be accessible even though there is a downtime in the server. And next we have a DB. Yeah, sorry. Yeah, we use MariaDB Caldera cluster. Why we need a Caldera cluster here? So the DB service will be running in all controller nodes, and each controller node will write different data based on the user request. So here the Caldera cluster provides the capability to sync all the data. If one data is written to one controller node, that will be synced to another in remaining controller nodes. So there won't be any data missing or say, loss in the DB level. And next we have messaging. So in a cluster we have there will be lot of API requests from the users. If there is no messaging service, all the requests will be fall into one place without a priority or severity. Maybe the backend couldn't handle and may go down. With this service, the API request will be queued based on the priority and severity, and provides response as the priority of the request. And what are things handled here is API node failure. So if any node goes down, so the load balancer will keep that node and goes and send the request to the node which are actively up. And EB node failure with the Cairo cluster, the data will be singled across every node. So there won't be any failure, loss of any DB level data, and the message queue failure. So every request will be a response at time, even though there is no failure of node. Let's move to the data plane. Data planes where our entire workflow will be running. It's divided into compute storage network. In compute, as I said, this has a computation power. It will be running the VMs in that particular node. So suppose suddenly the one compute node goes down, the next compute node in the line will be taken care of the VM which is created in that node which is gone down will be restored in next host. So there will be no VM downtime in the computation level. You can see the image here. See, if this node goes down, the next node will sense the node that goes down and will try to run the VM in this node with the same data and configuration. And next storage. The storage along with the Cinder, we are integrating the chef with the Cinder. Why we are using a chef means it is a in Cinder we can't process the distributed level storage. It is a single we can only set up a single machine with this Cinder storage. By using chef, we can able to run multiple storage nodes So, and the replica will be created across all nodes based on the number of nodes. So, even if there is a node system or disk lost in that node, the data won't be there won't be lost in loss of data in the application, and the data will be present in all other nodes. And it also has a self-healing mechanism. So if there is any miscalculation, misconfiguration in the part of the workload, it has the ability to heal itself, heal itself. Yeah. And next we have network HA. Network HA, we have a L3 HA. It's a VRRP protocol, which is a virtual router redundancy protocol. Let's say in one network node, we have a we have the router here. We have router in the first node. If that node goes down, the router and the IPs which are created under it will be replicated to the next network node. So there won't be any network network failures there, and the protocol various DVR distributed virtual routing, which founds the shortest path based on the next hop count and send the request to the. If a one node lost, it will finds the next node which has a shortest path and transfer the traffic through that server. So what are things handled in this plane is hyperlevel class will be handled by VM line migration, storage node loss. We have a 3x replica of all data. So if one node goes down, we able to fetch the data from the next node, and the network node failure. As I say, if one node goes down, the network will be created in a next network node. So as final, what I'm trying to say is HA is succeeded by combining all three layers, all infra, control plane, and data plane layer. Minimum 3 nodes per core. Like each roles must have 3 nodes to achieve production level HA. So if even though one node goes on, the another two has capability to manage the entire cloud application. So and also to avoid the single point of failure, try monitoring the servers using Prometheus and Grafana, and try to make some failover testing. Check how the server behaves in this point of failure, how the server behaves if this network goes down. Have to test in every point of view before moving to the production level application here. And then the one layer for the HA is, if there is no HA in any one layer, we can't say it is a processable application or a cloud. It will put every company data into risk. So from this presentation, I guess you would be understand how the HA plays a crucial in all into production level applications. So I think that's it from my side. If you have any question, go ahead and ask.
Any questions for Krishna? So how many of you are already working with OpenStack in these? Anybody who is new to OpenStack? Okay,
Yeah,
I think
if you have any doubt in OpenStack also, you can come out and speak.
okay.
Anybody?
Anybody who has an experience working in OpenStack already in a production grade setup, they'll be knowing how important high availability is when it comes to a production setup. So this session is just a high level information on how the different layers of OpenStack, because there are multiple layers, and in each layer we have to ensure that there is no single point of failure, because of which the complete cloud goes inaccessible or down. So for any production grade deployment, a vanilla OpenStack setup is not quite acceptable. So we have to make sure that each and every layer we have sufficient high availability in place. It could be any solution. It could be, so sometimes there are solutions outside OpenStack also. For example, the Ceph storage which was shown here, Ceph is a different project. It's not related to OpenStack, but it integrates quite well with the OpenStack. And in most of the OpenStack implementations, I think Ceph is very popular, which provides the distributed unified storage backend for the OpenStack. So there are different layers, and in some cases, it is with the help of external tools and softwares, with which we ensure that the high availability is ensured. So, anybody wants to ask any question, or maybe if you are more interested in knowing, see, this is a very high level session which is going on. If anybody wants to deep dive, understand each and every component, you are always welcome to get in touch with Krishna. He's an expert in OpenStack and Ceph as well. So they have been involved in multiple deployments with the production grade deployments, and they know how high availability works, how to avoid single point of failure, and how a resilient architecture looks like. So VMware days are fading off as we see. So OpenStack as an alternative to VMware, the closest alternative to VMware. The more and more we try to understand the OpenStack, it will be good for us. So anybody who's interested, definitely please do feel free to reach out to Krishna or anybody else, Likit or anybody else to understand more. Probably, Krishna, do you want to share your coordinates, email ID, or uh, anything
I'll
on
share
the
it in the
chat?
chat. You can check it there.
Okay, you can just share it. If anybody wants to connect offline to understand more, please feel free to do so. So next is a session. Again, it is a session on Ceph. So it is from Deepak, who will be explaining the crush algorithm. So most of you would have heard about disk drives and RAID concept, which is very popular for ensuring redundancy, data redundancy, because hardware failure can happen anytime. So, but then Ceph as a project uses a different algorithm altogether, which is called crush algorithm. And using crush algorithm, how in crush Ceph storage, the data is placed in different nodes, and creates multiple replicas for ensuring ensuring that there is no data loss. That is what Deepak would be explaining. So over to Deepak. I'm sure that will also be a quite interesting session. Thanks once again. Thanks for Krishna also for your session. Let's move on to Deepak. Deepak, please take over. Thank you.
Hi, good evening, everyone. Am I audible? Audible. Okay. So let me share my screen first and then we'll start. Is it visible now?
Yes, please.
Okay. So, hi, good evening, everyone. I am Deepak Prajapati and I work as a full stack developer at Pinnacle Cloud Computing. So, today I'll be explaining about the Ceph distributed storage and the Crust data placement. As About the Ceph, Ajit sir have already explained a few words. I will add on to that. Before then that, we'll go with the traditional storage system, how they were and how people were used to do this. And what was the main challenges and the problem statement in that? So before, in the traditional storage system, the data was actually stored in a single server or the node, which was managed manually across the few. Okay. So there was a single point of failure. It was not distributed. It was not at all connected to the multiple nodes so that it can spread the data all over the cluster. So if at any point the server goes down, the people used to lose the data. Okay. So this creates the major limitations. And additionally, the data placement was handled manually or through the stack configuration. This means there is a no intelligent distribution, and over the time, some disks were become the overloaded and while other was underutilized. So this was also the one of the problem, and the major problem was the scalability. You can't scale your storage system from one to another, while it creates the huge challenge when it comes to the storage parts. Okay. So let's come up to the Ceph. What is Ceph? How does it solve this problem? So as my friend Likhit and Ajay sir have already explained about the Ceph, I'll just add on a little more to the Ceph. What Ceph is? So the Ceph is basically a distributed storage system. Okay, it distributed. When we say the distributed word, that means it combines the multiple server and make them as a cluster or make it as a unified storage where all the nodes are connected to each other and the data will be spread all over the cluster of the nodes. Okay. So here, even if there is a point of failure at one server or another, the another server used to be up and it takes over and rebalance all over the data. Okay, so there is a no data loss. So this is where the distributed storage comes up. Secondly, it is the horizontally scalable. Scalable in the sense, if we have few number of the nodes in the cluster or in the servers, and if we want to increase it due to the storage issue, we want to increase it. So even without having a downtime of our whole cluster or our whole storage system, we can scale it. Okay, because in the earlier time we could not scale up. So that was the biggest issue in the traditional time. While in the Ceph, we can increase it or scale it horizontally. So there is a fault tolerant also. Okay, and here another advantage is like Ceph can automatically incorporate them without the major reconfiguration or the downtime, which I told it. Okay. Let's go to this, how the data is placed. Okay. Yeah. So the data flow. First, we'll explain how the data flow goes to the Ceph. When we write something, it treated as an object. Let's suppose we have the storage system where the Ceph is deployed, and when we write some file ABC something, that file will be treated as an object in our Ceph. Okay. Once it is passed through the object, then it goes to the hash functionality. What hash functionality does it? It simply converts the object into the numerical values. So Ceph basically doesn't understand the object directly. It can't store the object directly to the OSD. So it has to pass through the hash algorithm. So that hash algorithm, what it does, it converts the whole object into the numerical value and pass it to the PG. So now what PG is? So the PG act as an intermediate layer between the object and the OSD. So what basically it does, it used to object into the placement group, the PGs. Okay. Now, when it is distributed to the PG, this numerical value will pass to the crust. So now what crust does, it takes the placement group and decide on which OSD the data should store it. Let's suppose we have the multiple node. Let's suppose we have the 3 node cluster. Among from that, the crush algorithm decide where the data should be stored in all over the 3 nodes, so that even if one node goes down or there is a downtime or the failure of the servers, the data should be still be available from the user side. Okay. The crush algorithm works on basically three things. First one is the cluster topology. Second one, the crush rules. And the third one is the hashing. This I'll be explaining in the demo time. And before going to the next one, let's understand about the OSDs also. Okay. So the core building block in the Ceph is the OSD. Okay. So what OSD means is like, it's just a simple one. OSD means object storage daemon. Each OSD typically represent a single disk in your nodes or the servers. Okay. So when you write your data anywhere, wherever you store any file or object in the Ceph, it is ultimately going to store and sit back on the OSD only. So each your physical disk in the server will be considered as a OSD when it comes to the Ceph. Okay. And let's understand this Ceph algorithm and hierarchy. Okay. Crush. So crush is basically the controlled replication under the scalable hashing. Okay. So as I explained earlier, crush uses the topology. Topology in the sense the nodes or the cluster topology. It takes it from there. It hash it. It uses some replication rules, which I'll be showing you in the demo session as well. It takes it from the topology. It has some rule which has been executed at the backend. Then once it is done, it passes to the hashing. Once the hashing is done, it passes the same to the PG placement groups, and then your data used to be stored in the OSD in the format. Okay. So here the simple rule, the placement logic is a very simple rule. What it follows is it takes off, start from the root, it chooses up the leaf. Leaf in the sense it picks some OSD from the each node of the cluster, typically a different server it would be, and then it emits return the result. That means when you write some object or something in the Ceph, it takes from the root one, root from the root, it takes the hierarchy of the topology or the whole diagram of the cluster, and then it choose the leaf, it picks up replication. Let's suppose if we have the 3 node cluster, then it picks up the 3 replication of the each the file which you're going to write, and it picks up one OSD from the each server, and then it writes it there. Okay, at the last it returns it at the write it. This is how the basically this rule follows. It takes up from the rule, picks up some OSD in the different server or the host, it chooses the OSD, and at the last it emits it. That is what the result is, the placement. Okay. We'll just go to the demo one now. Let me just quickly switch to the terminal. Let me just show my cluster first. My terminal is visible, right? Hopefully.
Can you zoom in a bit? Little more. Little more.
Visible now?
Little more. Zoom in. Yeah. Yeah, that should be fine.
Okay, so here you can say I have the cluster, the health here, and the service which is running over here. So here, what I'll do is I'll first show you what is the OST tree follow. The OST tree. Here you can say I have the 3 node cluster. The first node is like node 2, which have the 2 ASD, which is currently up, and the host, the master node, and the node last one. So all the nodes have the 2 OSD in each. Okay, so if I will write some object here, so what it basically will do is it will create the 3 replication of the each file. What will I write? And then it will store in one of the OSD from the each server. Okay, let me just show you. First, let me show you the crush map of this. Crush map. I'll write in .bin. Since it is now in the bin format, you cannot read it. So let me just convert this into the human readable format using the tools. Brush tool. Brush bin. Now let me just show you what this consists of. Here you can see this is what the crush map follows. Okay, so here you can see it shows how many local tries it has to follow, what is the descendant ones, and then how does it choose the nodes and all, then stability and the version, which I have shown you here. It chooses the leaf, right? It start from the roots and then it chooses the OSV, then applies the hashing algorithm and all those things, and then at the last it follows the same. Okay, so if you want, I'll show you the rule also which you used to follow. Let me just list out first all the rules and then I'll just pick one and then show you. Okay, OST crush rule Alice. So here we have the majorly replicated rule, eraser code, arbiter rule, and this is the one created by us. So this you can ignore it. So let me show you how the replicated rule works on. Okay. Here you can see the rule name and yeah, the operation. What it does is the same operation which I have shown you. It takes the first from the root, choose leaf. Here you can see the choose leaf from the first name and then the type of host. So that means it takes from the root here and it then choose what disk it has to write, and then it select the host and which and all the host it has to write, and then at the last operation emit. At the last, it writes the object into the OSTs. Okay, this is what the basically replicated rule it follows, and the whole algorithm is based on this. Okay. Uh, Let me show you. I'll just create one pool and write one object in it and show you how the whole writing the object into the OST is followed. Okay. So let me create one pool. Create OpenInfra. The pool OpenInfra has been created. You can see here. Now let me write one file into it. Windows. File. Okay. So I just written one file into my pool, which I created just now, OpenInfra. Here you can see the OSD. This pool has been treated first as an object, then it has passed to the PG, and then followed by some hashing algorithm, which converts the normal object to the numerical value, and then it choose some OSD from all over the cluster, and then it used to write it. So OSD number 1, 4, and 7. If I just show you here, OSD 1 is from the master node, and then 147, right? OSD 1 is from the master node, OSD 4 is from the node 2, and OSD 7 is from the node 3. So here, what we can see is from all the over cluster, it chooses all the 3 nodes. It took one OSD from the each nodes and written the data over there, right? So even though if one of the nodes fails here or goes down or goes out of the cluster, you will be having the data still spreaded over the cluster. But the same thing when we comes about the traditional storage system, there was no thing. If my data is written here in the node 166, and if this goes down or this goes out of the cluster, you will totally lose the data. Okay. And if I show you the whole details of the OST, let me just show sudo ceph OST find OST.0. Okay. See the details of the OSD 0, sorry, not OSD 0, OSD 1. Since this data was written in the OSD 1, I'll show you the details of OSD 1. So here, if we just execute this command, you'll get the OSD 1 details all over things. See, the address where the OSD 1 is stored in the node 104 at the port number this one, and then it's the type is the virtual, the nodes, and the host is the master node. And the crush location, if you can see here, it follows the root as the default, which I have explained you earlier only, and then the host is the master node. So this was the whole things. How does the Ceph rule determines the object has to be treated as the numerical value, then it has to decide from the placement group and where it has to store. This is the algorithm which is follows. Okay, so this was all about this crush rule and this hashing and logarithm and how the data placement is being done using the crash rule and this in the Ceph backend. So Ceph actually does not store only where the data has to be stored. It actually calculates it properly using the crush tool and store it. Okay. I'll just show you the tree sudo ost sudo Ceph. Yeah, here you can see all over the OSD full details. Here you can see the class of the OSDs and then size and then here uses. You can see we have written just the data in the OSD1, right? Let me just find out this one. OSD1 here. In this, we have written some data. So the usage is 0.1 and plus the placement group PG, you can see it here. The all over it is maintained. Okay. So yeah, this was all about from the command line. If you want, I'll show you the Ceph dashboard also. From there, you can have a look on this everything. Let me just quickly switch to the Ceph dashboard. This is my cluster, which I have just shown you on the command line. And yeah, here it is. So this is the whole OSD, which I just shown you here in the command line on the graphical user. You can see the PG status, everything, and the size, and everything's. And I'll show you the pools also, which I created the OpenInfra here. The replication you can see as I had the 3 node cluster, so it created the 3 replicas. See, defaultly it takes the 3 replication actually. If you want, you can increase the replication count also. This function there. So yeah, that's all from my side. If you have any doubt, then you can go on with the questions. I'll be happy to answer.
Thank you, Likit. That was a interesting session. A lot of internals of self storage. Anybody has any question? It could be anything. Please feel free to ask any question.
Yeah,
Uh,
I'd love to answer.
the last session was little bit internals of self storage. We had 2 self sessions. Though it is not part of OpenInfra projects, but still, when it comes to OpenStack, that is very popular storage backend, which is currently being deployed in many production setups. So we thought we'll have some additional insights on Ceph project as well. That's why we included Ceph. Any questions? No questions?
Hello, Deepak.
Yeah, hello.
So can you create a new crush role and create one pool, please?
You want me to create a new pool?
New crush rule. Not pool. New crush rule and assign the rule to the pool. So many details.
Sorry, I didn't get you.
I mean, create a new crush rule first.
You want me to
Crush rule.
create a new crush rule?
Yeah. And assign that crush rule to the pool.
1 second.
Either go with the CLI or the dashboard also. Okay.
I'll go with the CLI. Second. I'll just name it as Second. One thing, I think there's some error in the command.
Or you can show in dashboard.
I'll one sec. Question. Yeah, it is. I just created. Next one.
You already did it. Thank you.
What are we trying?
No, we just created one this crush rule and just apply to the one pool.
Okay.
Crush rule is visible.
Yeah, okay, Deepak, thank you.
Okay, thank you, Christian.
Okay. Thank you. So anybody else has any queries? That's fine. Anyways, Deepak, you can also share your coordinates so that anybody is interested in deep diving, uh, they can connect with you offline.
Okay,
Okay.
I'll just share in the chat box.
Yeah, that should be fine. Okay. So that's it with the sessions. I don't know if it was an overkill with three different sessions. Yes, two were from Ceph and one was OpenStack. So uh, we'll continue trying to deliver such short sessions, and we always wanted there's an open source community, right? It's always uh, uh, works when we listen to more people, their experiences. It need not be in the same topic. It could be a different topic within the open infra projects, any of the projects, open source experiences, how they did it, and how, or maybe some tricks, tips which they can give it to others, and all those things. So it need not be a structured session like this. It could be a demo or any format of which people use. Ultimately, the aim is to share the knowledge. So anybody who has an idea on a particular topic, definitely that would be helpful for somebody else across the globe who has been looking for help. So that's how the whole open source community grows. So that is the core idea of the user group. And we want to listen to more and more users. We want more and more volunteers to come up uh, and speak. And that is also an opportunity because, as you know, it's not enough if you are working in your organizations. You should be able to articulate and explain it to others. Not necessarily, it's always about the technical topics. It could be generic conversations also, until unless we are able to articulate things in a right way and convey the proper message to our management, uh, it won't be as effective as how we think. So definitely, this is an opportunity to come together and contribute to the open source community. Most of us are consuming open source, so there are multiple ways to give back. Either you volunteer to as a coder, you contribute your code, or you contribute your time in such user group activities. It could be in any format. There is nothing, there is no strict guidelines on how you can contribute to an open source project. Every single bit of effort people put towards the community is always a welcome. And that's how open source projects work. If people don't volunteer, right, we will not have open source projects. So that's the core idea once again. So having said that, our little effort, what we are trying to do is we want to do this in a consistent manner, and we've been started this into 2025. It was a quite a bit of revival of the user group. Now in 2026, yes, this is the first session, and in a regular basis, I'm not sure how many of you are already part of this meetup group. If people have not joined the user group, always welcome. Please join this user group. The most of the communication on the meetups, regular meetups, everything happens through this meetup. If you have not logged in or created an account in meetup.com, please search for Indian Open Infra User Group and become a member so that there is regular communication which you receive. And on a regular basis, as I said, we want more and more community volunteers to share your open infra stories. Uh, and looking forward to have more and more speakers. Then next topic is it's not a technical topic. I just wanted to explain where we are heading next. So soon there will be a KubeCon India 2026 that is scheduled for 18th and 19th June in Mumbai. Anybody in this who would be interested in joining the KubeCon 2026 are already registered for the event? Okay, so if you are in any ways coming to Mumbai in June 18th and 19th, you can find the Open Infra Foundation exhibiting there in this conference. And on the sidelines of the conference, what we are trying to do is we are setting up a meetup dinner for all the community members in Mumbai. So it will be on the sidelines of KubeCon, and the dinner meetup will be on 19th June. That is the second day of the conference. And we would like to invite all the contributors, speakers, volunteers, everybody who are there in Mumbai at that date. And that will be quite an experience meeting different people from different parts of India, now people from outside India who can share a lot of insights, and it'll be a great networking as well. So if you again please make sure that you are part of this meetup group so that the communication can reach you on time. So I'll be sharing soon the RSVP link, where if you are participating in any ways in KubeCon, you can let us know, and we will meet you there in our scheduled dinner party. So that's it for the next exciting event that is coming in. So based on the people's response, we will plan bigger and bigger events. So soon, probably this is a testing event to see how many people are showing interest. Number one, if we see there are many people who are interested in actively contributing to the user group, next year we'll have a Open Infra Summit in India, probably in Bangalore, uh, which will be a 2 day event with a lot of technical sessions and from speakers from all over the globe and in India. So it's all based on how many people express their interest, and they actually contribute. I contribute in the sense it's all volunteer based, right? Nobody is working in any of these people are working in different organizations. So open source community works only when people volunteer. It could be anything. Volunteering does not mean like only if you conduct a session like this, you are a volunteer. Nothing like that. If you say you can help us in registrations of the event, yes, that is also volunteering. If you can arrange a logistics, anything part of logistics for an event, that is also volunteering. If you are directly contributing the code, source code, yes, that is also upstream code, that is also contributing. So there are multiple levels of contributions, and all together actually helps in bringing out a very successful open source community. So please do register for this meetup group, become a member, and going forward, you will receive more communications regarding this dinner. And you can always have suggestions, your own suggestions. If you are interested in having a physical event instead of virtual event, yes, we are open to that as well. And everything depends on how many people we have. So, and we are open for all kinds of opinions based on people's, because this is a user group. There is nobody, no single person having his say. It's always the user group which decides. So the users are the core of user group. Whatever opinion we collect from them, based on that is what we will lay out the roadmap for the next upcoming sessions. So if we don't have any other queries, we can wrap up for today. Any last bit, if you have any queries in regarding this user group, their activities, how you can contribute, anything, please feel free to ask before we wrap up. Anybody wants to introduce to the user group? I can see a few new people. If you want to introduce yourself, please, that will be a great help. Aryan, Vaibhav, Via, do you think you want to introduce yourself?
Hi there, Ajit and
Y-
everyone. I
Yeah,
am Vaibhav Sarvade and
yeah,
I'm
hi,
working
Vaibhav.
in C dot.
Okay.
Okay,
CDOT
so
in
we are
Bangalore?
also working on this OpenStack.
Okay. CDOT in Bangalore or
Yeah, Delhi.
Delhi? Okay. Okay. So, how you are already using OpenStack? How is it?
Yeah, we are using and it's
Okay.
deployed in field. Now we are currently means performing a migration kind of thing
Okay. What kind of
from
migration?
the old OpenStack to the new one.
Okay, you are like upgrading. Okay.
Yeah, upgrading.
Okay. So which version to which version?
Uh, Currently means we have deployed using these dev packages,
Okay.
but we are moving towards this Cola Ansible one.
Okay. Okay. Great. Great. I know you're also
So
using Ceph.
yeah,
Okay. Good. So how big is the deployment? You are talking about?
it's quite big. Means very big actually.
Okay. Numbers like how many servers?
Um, 1,000 I think.
Oh, that's too big.
Yeah, that's too big actually.
Okay. Okay.
So
So
recently I have developed a tool which
okay.
converts the running OpenStack dev package deployment to Cola Ansible one.
Okay. Okay. So migration. Sorry. Yeah, migration, right? For migration.
Yeah. So
So
the whole means this normal dev package deployed cloud will be
mm,
migrated to Cola Ansible deployed cloud.
okay. Okay. Cola Ansible should be easier
Yeah,
to
so means
maintain and
management is
use.
quite easier for that,
Right.
and
Right.
that security issues will also be reduced.
Correct. Correct. Definitely, vanilla OpenStack will not give you that kind of security aspect of all the six.
Hmm.
Cola has all these things inbuilt, so that will be easy for user and maintaining also. It will be
Yeah,
easy.
maintenance also easy.
Right, right. That's great. Yeah, that's great. But by any chance you are in Mumbai, you'll be in Mumbai in June?
Uh, I don't think so. Means I
Okay.
might be.
Because KubeCon is a very popular event. I think there will be a great footfall. Every
Actually, we have met in that Paris, I think.
oh yeah. Oh, okay, okay, okay. I remember. I remember. I remember you from CDOT Bangalore.
Yeah, one person on that Binup.
Okay, okay. Oh, he was in Bangalore. You were from Delhi, is it?
Yep.
Great, 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 great thing. Definitely, Vaibhav. Thanks for attending. Please, if your migration experience and all, we would love to hear because that is where those are interesting topics. How
Okay.
you manage to migrate and all that. That will help the community to understand how people are using OpenStack,
Hmm.
different challenges you are facing. Right, migration is not that easy. You'll face
Yeah,
a
means
lot of
running
challenges.
cloud is very difficult to
Right, right.
migrate a running cloud actually, and without any downtime.
Correct, correct. So that those kind of challenges and real world environments, right? That will help everybody. I'm sure many people will be interested in knowing how it is. So please feel free to have a schedule a session for upcoming meetups. Anytime.
Definitely, definitely.
Yeah, that will be great.
Okay.
Yeah, thanks for that.
Thanks, Ajit.
Yeah. Anybody else? Aryan, Priya, you want to introduce
Yeah, I
before
can go
we
ahead.
wrap up? Yeah,
Yeah.
Aryan.
Hello, everyone. I'm Aryan, and I work as a security engineer in a cybersec startup called Blue Flag Security.
Okay,
I don't really work around infra, but I thought it would be nice to see what exactly is going on around OpenInfra, so I joined here.
great, 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 great. So,
Yeah.
by any chance, are you already member of this meetup group or you just joined?
No, no, I was a part of Meetup group. That's how I
Okay,
got the notification and I came here.
okay,
Um,
okay, okay.
yeah.
Sure, sure. Sure, we had a cyber range session last meetup,
Oh,
which is
okay.
not directly related to
Hmm,
OpenStack, but
hmm,
still it was quite interesting. People would like to know how we can create a cyber range and all those things. So
okay.
we had a speaker from Stockholm for last meetup who had built a cyber range product, and he was explaining it. Was quite helpful. It was a quite interesting to like that. Any topic you would like to share your expertise, that will be great on the security aspect.
Okay.
Or if you want to know how we handle the security aspect in these OpenStack clouds, right? Cloud environments.
Hmm,
Yes, you can always connect with us, discuss. It's always give and take, right? So you
yeah.
can you can also take your help understanding on the security aspects. So you are based in Bangalore,
No, I'm currently in Hyderabad.
Hyderabad. Okay. So any chance you are planning for KubeCon 2026?
Uh, Not really. I generally, so I don't think I'm gonna make it this time because I generally, sometime around May or June, it's very occupied for me.
Okay, okay,
But I don't know, maybe at the last moment I might I might register for it.
okay.
I think
Because
that
last time it was in Hyderabad.
yeah, and last time when it happened, I think it was somewhere around August. I was outside the city.
Correct. It was in August and it was in Hyderabad.
Yeah.
So this time I think it is in Mumbai. So we are planning to have a meetup for like 200 people,
Hmm.
community members
Yeah,
on
that's
the
really great.
sidelines of the event.
Hmm.
Okay, but again, everything now boils down to the number of people, right? That is the thing. We can arrange things, we can bring in the logistics, arrange, organize things and everything. And ultimately, when people don't turn up, that's when is the no difficulty.
Yeah.
We had some previous bad experiences also. People committing and they're not coming. So it happens. We have to handle that anyways. But still, I'm just trying to see how many people are there in Mumbai in June so that we can have a very nice meetup on the sidelines of this QCon. QCon will be very popular, right?
Hmm.
So
Yeah.
we are expecting a lot of people.
Okay.
Okay, Adam. Thank you. Nice connecting with you.
Thank you so much. It's nice to meet all of you as well.
Thank you. Andrea, do you want to introduce? Okay, I think he doesn't want to introduce. Okay, guys. So thank you very much once again. Thank you for attending. Please do share this information with your friends circle also. The more and more we have participants and volunteers, we are happy. So please do help in sharing the word of mouth and uh, in taking the membership in meetup.com. and be part of this community. Thank you very much. Have a nice day. Thank you all.
Thank you. Bye bye.
Thank you.
Bye. Bye.